Hello all, welcome for today's interaction. Today we are going to discuss about fifth chapter lines and angles from class 7. Moving on to subtopic. Here there are four subtopics are there. First one is introduction. Next one is related angles. They are complementary angles and supplementary angles. Next one is pair of lines. Maybe they are intersecting lines, transversal, angles made by a transversal of parallel lines. And then checking for parallel lines. So these are the subtopics from this chapter. So moving on to first subtopic. Here, first subtopic, if you see, let us recall, as you know, how to identify different lines, line segments and angles in a given shapes. Once try to check it out about lines, line segments and angles from the given figures. For example, here, what are the line segments from here to here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 4. We have nearly 20 line segments are there. Similarly, 1, 2, 3, 4, 5, like that. We can count the line segments also from this. Also, we can count where the possibility of angle formed. And for example, if a letter M is there, here one angle there is a possibility of form and it is reflex angle and it is angle. And do we have any acute angles or any other type of angles are also formed there? From this figure, if you observe carefully, so here it is obtuse angle, and here if you see this is 90 degrees right angle, and of course this is acute angle, this is obtuse angle, and this is reflex angle below the M at this corner. So there are all type of possibilities are there from these four figures. Maybe line segments and angles are also there. So let us recall. A line segment has, of course, you know very well, two endpoints. If we extend either directions endlessly, we get a line. Also, recall a line segment that extends endlessly in only one direction is called ray. So, observe the below figures. First of all, figure 1 is representing line segment because both sides it has endpoints, no, P and Q. So, it is a line segment. And figure 2 represents lines because it is either sides extended with representing with arrow mark means it doesn't means it is extending either sides endlessly. And the third figure is representing a ray because it is extending only in one direction now, as we discussed, only in one direction is called ray. So next slide, and again recall that an angle is formed when lines or line segment meet at endpoints or other than endpoints also. From figure 1, here three line segments are meeting at their endpoints. But from figure 2, line PQ and RS are meeting at point O, not at endpoints. So, in both the cases, there is a possibility of forming the angles. There is a possibility of forming the angles. So, here we can discuss angles formed in both the situations. For example, from the figure 1, there will be a possibility of three angles are formed. From figure 2, there will be a possibility of two pairs of angles are formed. There will be a two pairs of angles are formed. One more here, from figure 1, the angles formed, for example, if you say angle A, that is joining of AB and AC, as A is common point for both AB and AC. So angle formed at vertex A. So angle A can be representing also in angle ABC or angle CBA or angle CBA. So now need to understand the difference between what is angle ABC and M of angle ABC. So angle ABC means just it is referred to angle only, but M of angle ABC means measurement of its angle, its measure. So Moving on to next slide. Moving on to next slide. So the next subtopic is related angles. Next subtopic is related angles. So in that the first subtopic is complementary angles. Complementary angles. So in these complementary angles, what is the meaning of complementary angles? What is the meaning of complementary angles? Sum of the two angles is 90 degrees. Then this pair of angles are called complementary angles. This pair of angles are called complementary angles. So from the figure 1, if you see, we can say 30 and 60 are there. So 30 plus 60 is 90 degrees now. So we can say its sum is 90. Therefore, figure 1 is representing pair of complementary angles. Similarly, what about figure 2? Sum of 35 and 65 becomes more than 90, it is 100. So, are these two angles are complementary? No. We consider a pair of complementary angles are x degrees and 90 degrees minus x degrees. So, from this, we discuss the complement of 60 is 90 minus 60, that is 30 degrees. So, we can say that complement of 60 is 90, complement of 30 is 60. Why? Because complement of x is 90 minus x, complement of 90 minus x is x. So whenever you are questioned about complement, we should subtract the question value from 90 so that we will get the result. Now, supplementary angles. You know, some of the measures of two angles is 180 degrees. Then the two angles are called, the pair of angles are called supplementary angles. So from figure 1, are the two angles are supplementary? 120 degrees and 60 degrees. So sum of 60 and 120 is 180. Yes, we can say this pair of angles are supplementary angles. Similarly, what about second figure? 68 and 112 is there, no? Here also, the sum becomes 180 degrees. So we can say this pair of angles are also supplementary. Let us consider a pair of supplementary angles B. X degrees and 180 minus x degrees. So here both are supplementary angles to each other. From this we can say we discuss supplement of 100 is 180 minus 100 is 80. So supplement of 100 is 80. So supplement of 80 is 180 minus 80. The result is 100. That way we are going to discuss. From the information what we discussed so far, let us have some kind of discussions from think, discuss and write one and second one from the textbook. So can two obtuse angles be complementary? Actually no. Why? Because one counter example is enough to declare the truthness of the statement. So obtuse angles means the angle which is between 90 to 180 degrees. So let us consider two obtuse angles and calculate its sum. So complementary means sum becomes 90, no? So as every obtuse angle is more than 90, so sum of two obtuse angles is compulsory more than, of course it is not equal to 90. So can two obtuse angles be complementary? No. Can two acute angles be complementary? Can two acute angles be complementary? So what are the acute angles here? For example, 40, 50. 40, 50, not only, actually here I even accept this is not only for this example, there are many examples are satisfied. Many examples are satisfied. Say for why I am giving you no, just listen here. For example, 40, 50 are acute angles. So 40 plus 50, 90 degrees. 1 and 89, 1 plus 89, 90. 2 plus 88, 3 plus 87, 4 plus 86, 45 plus 45, 50 plus 40. Similarly, 89 plus 1. So there are limited number of complementary angles are there where two acute angles are there. But whenever you are going to decide the truthness about the statement, whether it is yes or no, it is 100% no. Why? Because 70 degrees and 80 degrees are acute angles. But its sum is not 90, its sum is more than 90, no? 70 plus 80 means it is 150. So Though you have unlimited number of satisfied examples, but one counterexample is enough to declare the truthness of the statement. Therefore, can two acute angles be complementary? No. Ignore except, the word except idea. There are several examples are there, not only 45 and 45, as I told just now. Now, can two right angles be complementary? Can two right angles be complementary? First of all, value of every right angle is 90 degrees. So, sum of two angles must be 90. Then, this case also not possible. So, no. Next, can two obtuse angles be supplementary? Here, take 91 plus 91 is more than 180, not equal to 180. One example is enough. So, no. Can two acute angles be supplementary? No. 89 plus 89 is less than 180. No. Can two right angles be supplementary? Yes. 90 plus 90 equal to 180. So, from first exercise from this chapter, we are going to discuss all the problems in this exercise with the help of previous slides discussion. So now, moving on to next topic, pair of lines. So here, intersecting lines is there, no? First one. So let us understand with intersecting lines where we are taken from the nature, intersecting lines from the nature. As many of the junction for a road, it is these two lines are roads are intersecting. Is this line is intersecting this, and these two roads are intersecting, and railway tracks whenever they are crossing one track to another track again intersecting. Of course, here we can see the picture. L and M are said to be intersecting lines, at least if it have not at least if it has one common point. So two lines L and M are called intersecting lines. They have one point in common. This point of intersection is called intersecting point or point of intersection. So now next one. What about transversal? A line that intersects two or more lines at distinct points is called transversal. So from first figure, line P cuts the line L and M at more than one point. So P is a transversal. But second figure, line P is not intersecting the lines L and M at more than one point. It is intersecting at only one point. So in the second figure, line P is not a transversal. Moving on to next, angles made by the transversal. So when a transversal cuts the two lines A and B at two distinct points, so how many angles are formed? Here there are number is given 1 to 8 angles are formed. 8 angles are formed. Now among 8 angles, if you see a transversal line cutting across another lines M and Z creates 8 angles. As we discussed just now, 8 angles. It is out of 8 angles, we can form 4 pairs of special type of angles. They are corresponding angles, alternate interior angles, alternate exterior angles, supplementary angles. Supplementary angles means co-interior angles, co-exterior angles. Now, if you see corresponding angles here in the picture, what are the corresponding angles? Actually, in the next slides, we are going to discuss. See that corresponding angles in the last picture. Both angles must be same side of the transversal. One is interior to the between the parallel lines, and one is exterior to the parallel lines. So these are corresponding angles. Now same side but exterior, green shaded, they are supplementary. We are called this pair of angles are co-exterior angles. They are always supplementary. Then the lines are parallel, remember. And alternate exterior angles. So alternate exterior angles, alternate interior angles are same. Alternate exterior angles, alternate interior angles are same. Alternate means the red shaded angles are say either sides of the both sides of the transversal, and both are interior, and either sides of blue shade, either sides of the transversal, and both are exterior. So alternate exterior blue shaded, alternate interior red shaded, they are equal pair of angles due to alternate interior angles. And same side but interior, co-interior, same side but exterior, co-exterior, they are supplementary to each other. Corresponding angles or similar angles are always equal. Both pairs, this pair of angles are same side of the transversal. One is exterior and one is interior. Now, see, check it about individually. If two parallel lines cut by a transversal, each pair of corresponding angles are equal. So, as we discussed in previous slide, corresponding angles means both side, same side of the transversal, one is exterior, one is interior. So, blue shaded picture angles 1 and 5, one pair of corresponding angles, and violet color 2 and 6, yellow color 3 and 7, 3 is interior, 7 is exterior, and both are same side of the transversal G. And green shaded 4 and 8, 4 is interior, 8 is exterior, but 4 and 8 are same side of the transversal. In that way, we are going to discuss about corresponding sides. Now, alternate interior angles. If two pair of parallel lines are cut by a transversal, then alternate interior angles are always equal. Blue shaded angles, both are either sides, both sides of the transversal. Okay, one is left side to the transversal, two is right side to the transversal, and both are interior, means between the parallel lines L and M. In this case, angle 1 and angle 2 are same. Similar, congruent means same. Similarly, yellow shaded angles. So here right side and here left side, but both are interior. Such pair of angles are alternate interior angles. They are always equal. Now, interior angles. That means the parallel lines, two parallel lines are cut by a transversal. Then each pair of interior angles on the same side of the transversal are supplementary. So, if you observe here, 1 and 2 are same side of the transversal and both are interior, and 3 and 4 are both same side of the transversal. Both angles are same side of the transversal and both are interior. Such type of pair of angles are called co-interior angles. Of course, as you know, co-interior angles are supplementary. Supplementary means sum of the angle becomes 180 degrees. So, if two parallel lines are cut by a transversal, then each pair of exterior angles on the same side of the transversal are supplementary. Say for example, blue shaded angles 1 and 4, both are left side to the transversal T. So, these two pairs of angles are called co-exterior angles or exterior angles on the same side of the transversal. Such pair of angles are supplementary. So 1 and 4 are supplementary. Similarly, 2 and 3 yellow shaded angles are also co-exterior angles are supplementary. So now checking for parallel lines. Two lines are parallel. Then you know that a transversal gives rise to pair of equal corresponding angles. Just now we discussed equal alternate interior angles and interior angles on the same side of the transversal being supplementary. So when two lines are given, is there any method to check they are parallel or not? Yes. To determine whether the lines are parallel or not, need not to check all the conditions, converse of all the above conditions. Among all, any one of the conditions is more than enough to declare whether the lines are parallel or not. Now, the pair of angles formed made by a transversal with one pair of lines are corresponding angles or alternate interior angles, and exterior angles are co-exterior and co-interior angles. For example, if the corresponding angles are equal, then the lines are parallel. If alternate internal angles are equal, then the lines are parallel. If alternate external angles are equal, then the lines are parallel. If co-interior angles are equal, supplementary, then the lines are parallel. If co-interior angles are equal, supplementary, then the lines are parallel. Doesn't means if two lines are declared as a parallel lines, then the angles formed because of transversal, the 8 angles are, we have 4 pairs of angles are satisfied as per their property. Co-exterior or co-interior means same side of the transversal means supplementary. Either sides of the transversal means equal. Same side, but one is exterior and one is interior means equal. In such a way we discussed. But to cross-check whether the lines are parallel or not, we need not to cross-check all. Any one of the condition is more than enough to declare the given pair of lines are parallel. Now, moving on to next exercise. State the property that is used in each of the following statements. For example, given that A and B are parallel, then angle 1 is equal to angle 5. Observe angle 1 and angle 5. Angle 1 and angle 5 are same side of the transversal. Angle 1 is exterior to the A and B. Angle 5 is between the A and B. So means interior to the A and B. So pair of angles are same side of the transversal. One is exterior and one is interior means corresponding angles. Due to that reason, they are equal. And angle 4 is equal to angle 6. Then A parallel to B. So angle 4 is left side to the transversal. Angle 6 is right side to the transversal. Both are either sides of the transversal and interior. So alternate interior angles are equal. Therefore, the lines are parallel. That is the reason. And 4 and 5 are same side of the transversal. So they are supplementary. Therefore, A parallel to B. So co-interior angles are supplementary. Due to that reason, we can say the lines are parallel. So, for example, question number 5 from the same exercise. The given figure, angle ABC is 70 degrees and angle DGC is, find angle DGC and angle DEF. So, first one, angle ABC is equal to angle DGC. Why? Because given that AB is parallel to DE, therefore, due to corresponding angles, because angle ABC and angle DGC are same side of the transversal, this is exterior to the parallel lines and this is interior to the parallel lines. Therefore, both are equal from concept of corresponding angles. When AB is parallel to DE, BC is transversal. Due to this reason, we can consider angle DGC is 70 degrees. Similarly, angle DGC equal to angle DEF. Why? Because here angle DGC and angle DEF are same side of the transversal for DE when BC is parallel to EF. So, see also due to corresponding angles, we can say angle DGC is also equal to angle DEF. So, DGC also 70 degrees, DEF also 70 degrees. Similarly, we will discuss other sums in the same manner. So, let us discuss what we discussed in this chapter. Let us remember. We remember that a line segment has 2 endpoints. A ray has 1 endpoint. A line has no endpoints on either sides. Now, when two lines L and M meet, we say they intersect. The meeting point is called intersecting point. When the two lines L and M do not meet, however far produced, we call them to be parallel lines. So, these points what we discussed in this chapter. So, that's all for today's session. Thank you. All the best to you.